Hello, everybody. Welcome to another episode of React Wednesdays. My name is TJ Van Tol. I work as a developer advocate at Progress. With me, Dan Wilson. Dan, how are you doing?
Hey, I'm doing good. I'm Dan Wilson, and I work with Blues Wireless. We're the fastest path to connect IoT devices over the cellular network. I also help with the Enterprise React newsletter, and so if that's your kind of thing, Google it. It's got a lot of great content for those that care about React in enterprise contexts.
Cool. Well, I've got a couple announcements here I want to start with. So first of all, this is React Wednesdays. If you're new here, this is a show we run every Wednesday. We stream it on Twitch. If you're watching the recording on YouTube, you might want to check us out live. We do this at 1 o'clock Eastern US time every Wednesday. In a minute here, we're going to welcome Stefan Baumgartner, which you can tell me if I nailed that or not. I'm seeing some thumbs up, so I think I got it. Here on the stage, but just wanted to let you know that next week we're going to be talking React Context with Jeremy Ward. We've got React 3 Fiber, which I'm looking forward to because it's some cool animation video type stuff with React. Some stuff on the React developer tools with Jor Morgan, and we've got a super secret event coming up here as well that you can check out. And I'm going to drop the link into the chat, the React Wednesday site, if you want to check any of that stuff out. And I've got one additional plug for everybody today, and Dan hasn't seen this yet either. We're going to be doing a Easter egg scavenger hunt. So Easter egg, like the coding Easter egg type thing here at Progress. And we're doing this on the 28th, so actually a week from now, which should be pretty fun. And essentially, we've hid a bunch of Easter eggs throughout some of our sites. And the whole idea behind the stream is we're going to ask people if they can find them, and then we'll be giving away some prizes, and then we'll be showing how we created the Easter eggs and such.
That looks fun.
Yeah, it should be fun. And in case you were curious, because some people were asking about the dates, so Easter, at least as we celebrated in the US, was a few weeks ago, but the Orthodox Easter is, I believe, on like May 2nd. It's coming up. So, and at Progress, we have offices here in the US and over in Europe and Bulgaria. So we tried to split the difference and hold the stream then. So I'm going to drop the link in here. There's actually already an Easter egg hidden on the React Wednesday site. So if you're looking to multitask during this stream, you can check that out and try to find it. And in a second, I'll also drop the link to the form. If you do find it and you want to enter to win some prizes, you can check that out.
Super fun.
Should be fun. But for today, we're going to be talking about TypeScript. And to do that, I'm going to start by welcoming in Christian Pillsbury, friend of the show. Christian, how are you doing today?
Good. Looking forward to nerding out on TypeScript.
You want to tell people who you are for people that are just tuning in for the first time here?
Yeah, so I'm a senior consultant over at Digital Primates, where we do a lot of work in solving hard problems in streaming media, so TV on the internet, and in enterprise systems, often involving React. So that's me.
Awesome. And then I also want to welcome in our special guest for today. Let me switch screens here. Stefan Baumgartner.
Hi, folks.
Hey.
Hi.
Hey.
How you doing? You want to tell people who you are, that sort of stuff?
Yeah, sure. I'm Stefan. I work as a software architect here in Austria at a company called Dynatrace. So I'm from the center of Europe. It's close to 8 p.m. Around here, so I can see the sun setting already. And at work, I do a lot of things in serverless, mostly on Azure and AWS, but also have a long history of UI development. Right now, the last couple of years, also with React, and a lot with React and in combination with TypeScript. So I guess I spent the last few years or so digging really deep into TypeScript, making it kind of my topic, if you will. So it just kind of happened by accident that there's lots of things that you can talk about in TypeScript. And I started blogging about them and publishing about them and releasing this little book here with Smashing Magazine.
Ooh. Oh, you had it ready to go too.
I love showing that into the camera.
That's some awesome. That's some awesome art too.
It's beautiful.
I actually kind of miss. I feel like I'm reminiscent of when I actually bought physical tech books. I haven't done that in a long time, but it's just there's something so nice about being holding, and I feel like I learned better from having the physical book too than like looking over just some big PDF file online.
So this is why I worked with Smashing Magazine. So Smashing Magazine, there you go, is my publisher, and they put a lot of effort into publishing those books. You have, this is silver, that's some aluminium foil, and you have that here on the inlay as well, so it shines. It's glossy.
Wow.
And what I like most, so we have lots of artwork inside, like each chapter. Give me a second. Has some hand-drawn art from an artist that I worked with organizing a couple of conferences. So that's all hand-drawn by
Wow,
Rob
that's
Draper.
premium book.
Yeah.
Man, you should get into marketing, man. I'm like halfway to ordering this book right now.
It's not that I want to sell you folks this book, but I genuinely love it. And Rob Draper worked for the Golden Globes, so he did the artwork for the Golden Globes, and he decided to work with us on that as well. And my most favorite feature is actually this little red ribbon, because we picked the color that's actually the red squigglies that you get from TypeScript. So we tried to pick the exact same color for this red ribbon. I wanted to have it squiggly as well, kind of fluffy or something, but that didn't go. But so other than that, I think it's beautiful, and I hope the contents match up the packaging. I don't know, I can't judge, but I'm a little proud of having worked on that thing. So it turned out much better than I ever anticipated. If you think about styling and packaging and the whole production, and this is huge kudos to Smashing Magazine. So what they do is simply put amazing.
They're a great organization.
Absolutely, and it was a really fun experience with them. So they put a lot of trust into me as an author. So they knew, okay, the topic that's my topic, and I can select folks I want to work with. So I was able to select an editor working with me on that topic, who Sean Wang from AWS Amplify, Swix, he's called on Twitter. He's also very famous in the React community, who was a joy to work with on the technical side. And then, who's your favorite artist? Well, that would be Rob Draper. So let's ask him if he wants to do a book cover. And that was really nice. It was a really nice experience.
I must say, most of the people I know that have written books don't explain the process smiling as much as you did. It's an excellent endorsement for everybody involved.
Headline.
No, I can highly recommend them. They are a wonderful bunch. But yeah.
Well, it's really cool too. And I think I don't know, especially for the React world, I feel like the React world was kind of like the last framework to get on the TypeScript train, right? So it's almost like a good time for the React world, because I've seen so much more interest. I'm curious if you're seeing that as well.
Yeah, absolutely. So one thing that I noticed is there's the React not being a framework that has been written in TypeScript, but gets types on the side, by community maintained types, definitely typed. It's amazing how many downloads those types get compared to the actual framework. So last time I checked, you had about 8 million weekly downloads of React itself, and about 6 million weekly downloads on NPM of just the types. So I figure there's a huge demand of using TypeScript together with React. And to be honest, and I guess a lot of people have the same feeling, that of all the frameworks that are out there, I kind of have the feeling that React works best with TypeScript. Save
functional, declarative. Yeah,
exactly. And let alone for the fact that you write everything in JavaScript. So you don't have to have any additional language interpreters or templating interpreters to get autocomplete there. You just can rely on what TypeScript has to offer in terms of analyzing JavaScript and stuff like that. And TypeScript is a full-fledged JSX compiler as well. So TypeScript understands the JSX syntax. It can transpile it, all the flavors, and it's also very easy, to get JSX running with a little custom JSX factory function. So that was one of my earlier projects where I tried to, 50 lines of code, try to write JSX, but map it to DOM APIs like document create element, and it took me about half a day, and it's actually really usable. So I didn't expect it to be so nice and so straightforward.
A lot of times when developers are considering a switch like this, they're going to run into some unknowns and some uncomfortable scenarios as they get comfortable. Maybe they need a bit of a sales job. Like, why would somebody start converting into TypeScript? What benefits are they going to get, and what should they watch out for?
Okay, so that's a very good question. That's something I spend a lot of time with, because I was also one of those people who had to be convinced that TypeScript is a good idea. And when I approached TypeScript first, which was I don't know how many years ago, it usually got kind of shoved into my face from folks who wrote C# and Java, which like, okay, this is the Java for browsers. And I was like, oh, damn, I don't want to have Java in my browsers. That's the last thing I want to have. And it was mostly
an incorrect description. Like, yeah, it can be.
Absolutely.
Yeah.
I guess it's just alone for the fact that you have classes in interface, and you can implement any pattern that you get from the Gang of Four in TypeScript with those means. But there's much more to it. And if you do a little bit of research and a little bit of looking at Anders Heilsberg's talks from 2012, one of the creators of TypeScript, you see that first and foremost, the main thing they wanted to achieve is tooling. So they wanted to have JavaScript applications and try to get a tooling layer on top of it, so you get autocomplete, IntelliSense, just some sanity check that what you write is actually makes sense, might be quote unquote fail-safe, because TypeScript has this very unique feature that you can gradually adopt into using more and more types, which also makes adoption a lot easier. You can just start with a little bit of TypeScript, maybe do some annotations just in JSDoc, where you do some JSDoc comments, write your types in that, and that's good for a lot of people. And that's also when I'm just prototyping and stuff like that. That's the main way how I'm going to write TypeScript. And if I have a real project, I put on the compiler and write actual TypeScript. But up until that point, if I write a little node script or something, it's just JSDocs comments and types on the side, where I maintain a little type definition file, so I get more meta information on what my code is actually about. And TypeScript does a really good job of analyzing your code so well that for most of the time you don't have to write any types.
The type inference system is very powerful, and it's gotten better in the past major version.
Exactly. And if you do, you just can do as much as you want. And this makes it really unique, in my opinion.
Let's kind of stick with that for a minute. And this may be targeted at both Christian and Stefan, but let's say that this value proposition is you can just use as much as you want, but you don't have to use too much. From an architecture perspective, this sounds like a mess. How do you manage that?
Okay, so I guess especially if you say from an architecture perspective, you have to decide whether you want to start with a new project, or if you want to migrate an existing project towards TypeScript. If you want to start with a new project, I'd say if it's something that lives for a longer time, start with TypeScript directly, put on all the strict flags, like go all in TypeScript and make sure that it's coherent and makes sense through and through. If you want to migrate, this comes actually really handy, that you can just pick smaller pieces of your architecture, like small parts, small libraries, and transform them. You're not?
Yeah, so we actually just migrated an iterative infrastructure for TypeScript on a several 100,000 line project that we have in React.
Nice.
And so the biggest pain point in my experience, I would 100% agree with you that if there's any good reason to use TypeScript, you should start with TypeScript if at all possible. But if you don't, and even when you do, the biggest pain point in particular in the React world is, while you're 100% right that the community has been great for maintaining React types, with the unfortunate scenario that because React is Facebook, they really want flow. So
I guess they have to
as long as they can. But the community has been really great at maintaining and making sure that they are precise and accurate representations of the types for React. However, the same is not true for the rest of the third-party library community that is frequently required for working on React projects. So what you end up with is having to fight against poorly maintained and sometimes inaccurate representations of all but the simple use cases of components or similar things. So that's pain point one. Pain point two is while TypeScript does allow you to use like not strict enforcement, and it's gotten better with both major and minor version for scenarios that it allows you to be like, don't be so strict with this sort of scenario. The problem is once you get into dependency chain resolution on large code bases, you can't selectively say this file is TypeScript and this file isn't once you start going import A from import B from import C. And so every time you have one of those scenarios in the normal setup, you have to basically migrate a swath. And so it's completely tied to the module or the dependency chain in that way. That's really hard to extricate. And we ended up having to build an entire system using TS-lint with Webpack, and we're hoping we're going to be able to open source it so that we can narrowly declare. We actually have, just like ESLint, we can say ESLint enable, ESLint disable. We now have an infrastructure that allows us to say, here's where we want to enforce TypeScript, and we can do it at a block level. We don't know if we'll be able to open source it, but that was a very difficult and hard-won effort.
First, kudos for doing that. That's amazing, because you're absolutely right. You have to do it in chunks. You know, it just can be bigger chunks that dangle in your dependency tree. Absolutely, and depending on how good your architecture is, or how modularized your architecture is, let's put it like that, the easier it gets. If you have I wouldn't say, if you have a bigger blob of files that are somehow connected to, which usually happens with component libraries, which you usually happen to have in React, things can get nasty. That's true. That's absolutely true.
Yeah, data layer is almost always way easier to migrate than you. I 100% agree with that. Yeah.
Absolutely.
So Christian, I want to kind of drop back into your project you mentioned. So we talked a little bit about the pain and how you mitigated that, but what prompted the need to migrate? What were you hoping to get for the project benefits, stakeholders? Like, walk us through that a little bit.
So basically, we have a very complex server side where we already have generated JSON schema files for all of our endpoints, but it's a very dynamic and complex system that involves lots of data combinations, and those need to be managed and mitigated internal to the UI. And so what we're trying to do is make sure that when someone types, I want to grab this value from this payload, that in fact exists on that payload. And so we were solving some of those problems using things like AJV and our own custom context with hooks and stuff in React. But there was still a lot of cases where, because JavaScript doesn't know whether or not a particular property exists on a particular thing, we couldn't rely on, like I mentioned earlier, and that Stefan was calling out, is the type inference system in TypeScript is very robust and very powerful. So the more we can actually get types starting at the data and then flowing all the way down to how we're interacting with the data, the more likely it is we can avoid, especially in large complex systems, someone making a mistake on, I wrote this like pluck off of this complex data object, and that, lo and behold, that pluck is never going to be successful because that property doesn't exist on it. So we're trying to allow for like what TypeScript shines at, which is, I'm hoping we're going to get into some of the dynamic typing stuff, but between the dynamic typing, which is another way you can derive types, I use that very frequently to derive type A from type B, and the type inference system, between those two things, if you can get that infrastructure right and starting at the data layer, you're going to reduce the amount of times that someone's just making a mistake because the system is massive and complex. And since our system is massive and complex and dynamic, we want to try and allow for iteratively creating scenarios so that user mistakes and trying to have to work every time through all this the complexity is a non-issue, because TypeScript's just going to let you know that you've made that mistake.
That makes sense. And, that might be a good segue to start taking a look at some of this stuff.
Yeah, Stefan, I know you want to show us some of this, which I'm excited to see. So if you want to bring up your screen.
I'm unsure which one of those might be the better one. So let me just fiddle around with my Windows.
Yeah.
Okay. Alrighty, you get to see Visual Studio Code now. Great.
Yeah.
So I have one thing that comes from the dynamic static typing thing, which is some sort of Express style server where you where there's so much potential for having errors that I want to get to really nice types that you can catch basically everything, but I wonder if I get through that. Or the one thing that Christian just mentioned, where you derive types from previous ones. I guess that might be really nice to start from here. Let's see if that's not the one thing where I did everything already. No, that's nice. Okay, let me start. So what we have there is I want to maintain types for let's say an online store or anything that stores toys. And I created a couple of types. One is some sort of basic type, the toy base, where I have name, price, quantity, whatever. And then I have some subtypes of that, which are basically the base type toy base, and that's an intersection type, and some more properties to differentiate them from all those others. And this, you can think of that. So what other folks use is interfaces and extending from interfaces. So it's more or less the same thing. There are some nuances to what interfaces are, as opposed to what types are. But right now and how they evolved over time, you could say they are almost the same. And give me a second. I just lost you folks. There you are. Okay. And okay. So I create a couple of types. Here I have a toy base. It's kind puzzle. The kind is actually important because this is an intersection type, which means I intersect every possible and valid value of this one type with every possible value of the other type, making the set a lot smaller, intersecting two sets into a smaller set. So suddenly the types that are assignable to puzzle, to board game, or to doll are much smaller, or much less than early on. And I have this union type, which is of type toy, which can either be a board game or a puzzle or a doll. The nice thing is, if you do something like having this kind value here, as you can see, this is not a string, this is a specific string. So this is what they call, I call it unit type, but I guess literal type is the right word, where you say, okay, instead of all strings possible, I want to have this exact string. Here with material, I have a union of two exact strings. So material can just be plastic or plush. It can't be any other string. And this is, I guess, one of the most important things in TypeScript, that you have the ability to modify, to subset that all possible string values to some concrete and very discrete string values, because in JavaScript almost everything is a string. So you have lots of strings flying around. You do lots of checks on strings, and being able to pinpoint it to some exact strings is actually kind of nice. And I'm doing that for a reason, because if I specify this kind with an exact string, if I get a toy in here, if I see what properties I have with toy, I have all the properties that are in the base type. But if I look at kind, I can select between those properties, between those exact strings that I defined earlier. And with that, I can do switch case statements, where I say, okay, if I have the case board game, toy gets things like minimum age, what I have in a board game, the number of players, it suddenly becomes of the type board game again. Not all toys that I can have, but exact of this particular type. And I can do that, until I have, all of them. And then I have the toy down there. It just can be never, because I exhausted all possible values. So I know that if I jump into the default case, since I exhausted all possible kinds, this case can never happen. If your program runs into this case, it's an error. It breaks. So this is something that you can check for. Never is a beautiful type. It's the type that doesn't have any values. And if it happens to have a value, you possibly have done something wrong.
Yeah.
Ask your questions. I just write something.
Oh, real quick. Have you played with using predicate functions with the as cast as another alternative to this? I found that's a very powerful thing. So you
yes
could go the adding a special property that uniquely identifies, or you can use a
exactly.
predicate.
You are absolutely right. That's a wonderful thing. It's something like function is board game.
Yep.
K is of type toy.
Yep.
And you say, type predicate functions do a Boolean check, so they return a Boolean. That's one of the requirements for that. And you can say, okay, return what was it? Players in K. This is almost a similar check. So you because I just have players here in the board game type, and you can check maybe for all possible values there. And then if this returns true, you can assert that K is a board game.
Yeah, perfect.
That does exactly that. So and through what they call so let's declare a game which is just a toy. So sorry. Whoop. Yeah, const toy. And what folks usually call control flow analysis. You can have an analysis of your control flow. So if you say is board game toy, down here toy should become a board game. Exactly. That's what we have been looking for. So those are ways to move around the type space. So you have a bunch of values, and everything that you do in TypeScript is draw boundaries around possible values through those types. That's also, so those are basically the only graphics that I have in my book. It's charts of sets that intersect each other or unify each other, and you get a lot of set theory that you have from algebra and things like that. So that's one of the fundamental things if you work with types in TypeScript, moving around sets and making sure that the value is of a concrete set.
Yeah, and you're also highlighting the focus not just on a robust set of intelligently designed type primitives around algebraic types, but also how well that serves you as in the tooling side, because you're just hovering over and it's like, lo and behold, this is in fact a board game type, and it will give you an error. One of the things I was thinking about when you were showing the union types up top, I was from the tooling side, is if you were to write a property that's in conflict with the thing you're trying to union it with, it will give you red, it will show you red and say, like, this is not a possible union type, because you can't union things that are not consistent with it.
Exactly. Absolutely. Alrighty. And one thing that you mentioned, Christian, is especially if you think of maintaining types along the run and making sure that you don't run into errors that could be prevented because of human errors. Is something like that. So I have two other types that I need somewhere in my application. One is toy kind, where I have exactly this union of possible kinds in my kind property of all available toys. And then I have group toys where I use the same key or the same value, but for a key. So I can group them for board games, puzzles, dolls, whatever. First thing first, one thing that happens is if I write here dolls, nobody tells me that this dolls is not compatible to the kind that I have in my actual doll type. So those are incompatible, but nobody tells me. It's still valid, and I have an error that just happens through me not being aware enough, or just making a human mistake or something like that. And this is where I come into a field which I like to call low maintenance types, which are types that are going to maintain themselves, because up there is everything that you need to know. So there's no reason for us to write it again and again and again. So let's rather derive those types, those two, from the ones that we have already. And one is actually pretty easy. It's the type toy, and it's the property kind. So this is almost like writing JavaScript. It's the index access operator, and you can have a property as an access. TypeScript understands this and can fetch all possible values. You see them there, doll, board game, or puzzle, from the toy type. And the moment I change something in one of those type, which is here, it's dolls now, I get an error there, which is nice, but the derived type then says dolls. So it maintains itself, and I can make sure that if I use toy kind again, it's just like I expect it to be.
Yeah, and I think the thing that makes this so powerful too is, like, this example is purposefully a little bit simple to teach the concept, but in a real world, this will be some other developer that doesn't know your type system, right? So
Exactly.
those like little conveniences often are just an absolute huge productivity and error savings
Exactly.
gain. Is like those little things, like being able to see the editor, see what possible values are, is just it's amazing.
Well, it also just allows, like, if there's changes upstream, like let's say he added a new toy kind, like a new definition for another kind of toy.
Like the video game. So this is something that I prepared. I have a video game, and the moment I add video game up there in this union, I can make sure that toy kind down there has video game as well. Exactly. This also leads me to one case. I just created an assert never function, which takes a value that is just never, and if this value, or if this function happens, I throw an error. And I do that instead of the console log toy here. I can assert never that the toy that I get in there, I guess it's toy, is definitely never. Let's remove the video game for now. So right now, toy is never, because this case can never happen. And I can make sure that I have exhausted all my possibilities. So I can make sure that each case statement, or all case statements together, make sure that I had exhausted all valid kinds. The moment I add a video game to the mix,
I was hoping you were going to circle back around to the red, non-red.
There you go. The moment I add video game to the mix, toy is not never anymore. It becomes the video game. So I get
video game, or exactly.
Exactly. So I get an error that I didn't exhaust all my possibilities. So I can say, okay, case, video game, and do something. There you go. And suddenly this thing compiles again, because I exhausted all my possibilities.
And, when I think about the human work you'd have to do this in, non-TypeScript, it's a lot of opening files and trying to interpret someone else's code and remembering stuff. And then, like, I don't know about you, but I get distracted a lot. So I might have to go back and look at it again. And, this is like having a little assistant that sort of manages collecting all this information for you and putting it where you want. Like, how could anyone not want this? So how much does TypeScript cost?
I'll buy $1,000 right now. I can tell you it's free, and if you buy 2 of them, you get another.
See, perfect for marketing. Born marketer.
Alrighty. So yeah, and it's if I want to continue this example, it gets kind of repetitive, but I would have to update group toys as well, just like Christian said. I would have to do the same thing as well. But what I can do is I say, okay, this is an object, and I create this object on the fly. I can say, okay, for every property in toy kind, create the toy array. This should, and if I have over that, I get it expanded to all the possible values that I have. If I remove video games, it goes away. If I edit again, or if I add another again, group toys becomes complete again.
It might be good to explain that syntax, because for those who are deep in TypeScript world, I get what you're doing, but it's doing a lot with a very little. So.
I've got a blank stare going on here.
I wasn't going to say anything, but I was like, what is that?
It has been a while, but if I'm not mistaken, this is a mapped type, which basically, if you put those brackets in there.
So is anyone familiar with the for in loop that was introduced to JavaScript? Think of this as like a for in on objects, but for typing.
On a type level. So you, since toy kind is this union of those possible values, you can have a loop where you get each literal type out of that union and do something with it, like creating a property in this object. So I open up a new object, or I open up a new object type. It's an object type. I can add total number of toys numbers. Well, I can add any property like I would do it. No, I can't. Damn it! I made a mistake. Sorry.
Yeah, it's a little tricky with the.
I would have to do a union.
Yeah.
An intersection. Number of toys. There you go. So I have this number of toys, and then I have all those possible games. You wouldn't do that. But what I do is I go over through all those properties and select each one of them and do something on the right side. And I can even do a little bit more with that, because one thing that I don't like is I have those group toys now, and yeah, it maps all those necessary keys to an array of toys, but actually that's wrong, because it's not just an array of toys, it's an array of a specific toy. Board game is an array of board games. Puzzles is an array of puzzles. Okay, there's a possibility for that as well. So
you're going to do a generic?
I'm going to do a generic, and this is where it gets really fancy. I'm going to create a generic, and I'm going to use another generic. But I create a generic that is called GetKind, and I'd say this is one of those types that you can, if you have a structure like that you can use all throughout your programs, no matter if you're dealing with toys or not. And I want to I want to have from a particular union, or it's called it union. I want to extract I want to extract a specific part of that based on its kind. So, and the kind can be something like, okay, if I do some documentation, the union would be dolls or doll or board game, and the kind would be doll, like this one literal type. And I use the type called extract. So, and this is a generic, but it works a lot like variables in a function, which makes it really easy to get a hold of that. Instead of calculating things, you are working on sets again, like expanding them, narrowing them, whatever. And I use a type that's already been defined, which is called extract. And I tell you what it does in just a second. I say from this group, extract, nope, it's called union. From this union, extract the one thing that has a kind property that maps, that is exactly this kind that I pass there as an argument. So I can use that just like I would use a function and say, okay, get kind from my toy union, select ball. And what I get is I get this one ball. Or I say get board game, and then I get everything that is a board game. Okay, so that's what it should do. And the extract type works like that. And this is one of those TypeScript features that blew my mind when I started working with TypeScript, which is called conditional types. So what it tells me is I have a condition there. It tells me if this type T extends the type U, then return T, otherwise return never, which is just like a ternary operator in JavaScript. And again, based on sets, if this one set that I put in there extends is a subtype of this other set, like they have common boundaries, then return the entire set, otherwise return never. And if I put in an entire union of types, I say, okay, let's go with dolls again. If I say that this one type that has kind doll as a property, it's a subset of this type of kind doll, then I'm able to return the doll. And if I put in a union with all my types, with all my toys, it filters out those types that are not compatible, like which with the never type. So never is this one branch where they tell me, okay, filter out that one. Oh no, this is part of the same set. Return that back, and that's how I can move around this union that I had before. And if I use this type, I say, okay, get kind, use the union I had before, and the K, which is this one, it's either one of those in toy kind. It's not union, it's toy. I'm sorry.
Yep.
Make an array again, and suddenly I get them expanded like they should be. I get board game, which is of type array of board game. I get puzzle, which is of type puzzle. And with that, the moment I use something that uses group toys, function print toys, grouped toys. The moment I say, okay, for toys board game map because it's an array, I can make sure that the element there is an actual board game. It's even though group toys can have a lot, but this is a board game, and I only get properties of that board game type. So I can make sure that I have the exact type there, and I'm only allowed to assign properties of that type. And again, if the moment I change something throughout my types, like I add board games, first I get an error there because that's not part of that. That's nice. Same here, I get an error there because group toys suddenly has board games as a key. So that's the low maintenance type. That's types that maintain themselves, because the only thing that I do is defining the relationship to each other, yeah, and maintaining only my basic models. So the idea is that you just maintain your models, that you just make sure that everything that you have to maintain is the data that you're dealing with, but the relationship to each other and the way you use them, you can use those constructs like map types, conditional types, and so on, to have more types that maintain themselves the moment you change something in your models. And especially, like you said, teacher, when I use code from somebody else, I'm going to make sure that I just create types like that for my code, because the moment they change something in their models, I get updates on the errors. I don't have to make sure that I update my types according to their types.
You know, a lot of this reminds me of relational database work. Like you almost have like a third normal form of types here. And as I see you do this stuff, the syntax is a little bit different, but a lot of the benefits are the same. And so I wonder if anyone's taken that approach to explain it before. You'd never create a database and start duplicating data all over the place.
Yeah, that's a very good metaphor, actually. So that's I haven't done a lot in databases in the past, unfortunately.
Be happy about that. No one's ever going to call you and say, Stefan, the database is running great. Now, if you build an application, they're going to go, oh, you saved us so much time. But databases is what I call a no-joy job. If anything goes wrong, you hear about it. You never get complimented. The expectation is it always works, and stuff breaks at 4 a.m. You know what I mean? So,
but if you like,
not that I have experience in this.
If you like nerding out about set theory and like algebraic types, database, there are worse places to be than working on databases. I actually, you only said it as like a sentence in passing, but I actually think another reference point for what's going on with all this stuff is understanding that there's a very close, even at a mathematical level, there's a very close relationship between a generic type in TypeScript or in any type system and a function. So if you can like understand this as like, this is a function that's producing an output based on some input, and then as long as you understand what it is that like the function is doing with the input to create the output, that's like the hurdle of the explanation. So if we looked at all of your generics, it's like very dense because there's several, you're using 2 generics that are very powerful, but you can explain it in terms of a function where you're taking something that looks a certain way and you're taking a second argument, aka a second parameter in your generic, that's stipulating what it is you're trying to look for in the first thing, which is kind of like an object. And then from that, you're able to say, okay, look inside this thing, perform this. If you want to go into like imperative language, perform this operation on this thing to extract, which is a very imperative, to extract the thing that matches the thing you're looking for, and then use that as as input to this other function, which is your other type, that's then able to like produce another thing as a result of that.
Absolutely. It occurred to me that it's similar to functions when I wrote the book, because I had to be sure that I used the right names for things that you call, I call this a generic type, of course. How do you call the things in there, A, B? And the moment I wrote the book, I had to take a look, and they're called generic type variables. So it's like a variable, and you can set defaults just like in a function. And the more you do that, the more it becomes just like functions. And yeah, if you do something like the extends, which is the conditional type, which basically allows you to branch between to find your way through a couple of things. Working with set really helps because I have this type which is A is number and B is type 1, and I have a type which is B is of number, and no, I can't have two B's. A is of type string, and B is of type 2. If I do a check against B type 1, I can say this is a subtype of this. So this extends that one here. True. Go into the true branch. This does not extend that one here. It's not a subtype of that one. Go into the false branch. And then you start filtering sets. Then you have this big set of lots of values that are available, and then you shrink it down to more concrete sets.
Right. Or with Dan's call out of it being like working with a relational database, it's like a where clause where you're like, where the row data looks like this, whatever the this is. And so it'll be either thumbs up or thumbs down. And for the thumbs up ones, it's still in the set that you're trying to select. And for the thumbs down, it's excluded from the set, or it's the false case in the functional flow way of talking about it.
So one question I have is, I wonder, do you think there's a point at which people can get too overboard with making these types too complex? And my background here is, so I spent a lot of time in the Java world, and a lot of Java APIs were written by people that I think drank the generic Kool-Aids, would be one way of phrasing it, where you'd go look at the Java doc APIs and it would be like, oh, T defines or extends X as B or something like that. And there got to be a point where it became like the typing almost worked against you because it was so like esoteric and strange. So I'm curious if you think there's like a line where like, depending on what you're doing, like how crazy you should get versus trying to keep things simple, and how you think about managing that.
Well, TJ, one of the rules of computer science is all problems can be solved by adding abstraction. Except the problem of too much abstraction.
Exactly.
Oh, sheesh. Christian, do you want to answer that?
Honestly, yeah, I think that's more of a pragmatic question, and so the answers are inherently going to be pragmatic. So
we're gonna get the "it depends" answer. Pull out your card. You got a card that says it, right.
Yeah,
card up there.
We need an animation for this, like that just pops up big. It depends.
So if you're dealing with the massive code base that I was describing, I would say having a handful of really probably very dense, complex, compositional types that very few people are going to be able to understand will probably make everything downstream of that a lot easier. And so in that sort of scenario, I would highly encourage trying to make things that are self-maintainable, even if dense and hard to interpret for most people. If what you're trying to do is churn out something really quickly, and you want to get some of the benefits of having types to yell at you, do whatever can be most expedient to get those types in place, because if you change, let's say you have an API and you get a data, like a response back, and you have just this explicit type that you've defined, and you're like, oh, the data changed, it'll still yell at you. If you can make sure that the data that you're looking at doesn't look like that thing, and if you have to manually go in every time that change happens and say, tweak this, tweak this, tweak this, you're still gonna get that benefit. And so it's gonna be a lot quicker to just maintain that, because changing that is going to be easier to reason about and stuff like that. So that I do in fact think it depends, and it depends on like how in the code base, how, like, what is its purpose, how massive and complex is it, like that's where I would say the main trade-offs are going to be.
Yeah, I wholeheartedly agree. So it also depends really on your on the number of people using the stuff that you write. So the team that I work with at the company I work for creates a design system that is going to be used by possibly thousands of developers in-house. And we want to give them types, so no matter how they are going to use our component library, they're making sure that they get, that they are getting the right types. That's my little son there. If you like my Led Zeppelin shirt, he has a Queen shirt.
Nice.
Oh man,
Good.
runs in the family.
Well branded, a well branded family.
Absolutely. My little, the littlest one has a Rolling Stone shirt. But ich komme gleich zu dir, Schatz.
Does he have a favorite TypeScript type?
No, I
It's any.
That was not scripted, but already. I don't say it's the first time that happens. It happens actually quite a lot. Here's one thing, which is also part of the dynamic static typing article that I've written for Special Magazine, where I tried to type an Express server. And I won't go through all those types because they have even more with stuff going on. Not only have they conditional types, but conditional types in string literal types that infer subtypes. That's real. That's real mind melt there. But what I can do is I can say, okay, I write the get function and I add a string for the URL, which is okay, whatever, and I have those parameters again, like param1, param2, and TypeScript right now is capable of parsing those strings and extracting elements that follow a special pattern, like colon something. And then I have
a very new feature, by the way. This is
absolutely.
Yeah.
And I have a callback for that. And the first thing that I see is, since I use the get function here, I can make sure that the request has I might have a wrong type here. Anyway,
by the way, just in case that's going to be relevant later, the whatever, there is a typo in there.
Oh, damn it, yeah. Whatever. But the moment I'm here in the callback function, I already can see, okay, this is a callback function that has a server request of get, because I add the get parameter here. So at the moment I write request response that you have with Express, I can make sure that rec.method is get. So I'm not running into any situations where I say rec.method equals post, because that can never happen, because I'm here, I'm calling the get function. So it has to be get. It can't be anything else. So this is an error case that I can rule out by having those dynamic types. And also with my params, I can filter those strings and see which parts of that have a colon in front of that, and get the exact name of param1. So I don't run into things like, let's have user ID, and then inside I have user ID, but with a lowercase d. No, that's an error, because I can analyze the right pattern there, and I can say it's user ID, And also for the response, I got every status code from HTTP, so I can say res.send and status, and give me a status code that is not for 1,000, but for example. So, and for me as a user, so what I do here, I just write regular JavaScript. That's not TypeScript in any way. It doesn't have any types. But with me providing types like that, I can make sure that the consumers of my library, or the consumers of my software, get the information they need to not do any mistakes. And this is the case where all this fancy generic stuff and all those conditional types and things like that come in really, really handy.
I actually think one thing that you probably didn't call out, but I suspect is true of your over 1,000 people working with your code base. Those 1,000 people are not people touching the type definition. They're people who are relying on you to have written good, robust type definitions so that their code and their coding lives can be better. And so there's a difference between who has to touch the hard parts with these dense type definitions versus the benefits that flow out as a result of that.
Exactly.
Yeah, you're already giving me some ideas because I work in a similar scenario. We make at Progress, we make Kendo React, Kendo UI, right? Components that are consumed. We maintain it, but then we ship it out to lots of different users. So you've already given me some ideas. I'm now like looking at our APIs, going like, oh crap, like we could totally prevent this sort of thing.
Yeah, I mean, I'm looking at all this and just thinking, A, why would you not want to have this? And then B, who in the world could design this type system so well? We need to clone Stefan a bunch of times.
No, I did not design it. I'm just a consumer. So all the credit goes to the TypeScript team. I guess especially Anders Salzberg. He has, so he created C#, what was the lead architecture of C#. He created Delphi. He created Turbo Pascal. So he has 4 decades of defining programming language that have excellent tooling. So that is his shtick, I guess.
And C# typing today, it's also great. C# and types are also fantastically designed.
Yeah, I also think though, like inside your organization, there has to be somebody that can understand almost the level of complexity of designing a good database schema, because you're really designing a type schema for a code base. Like, I know we have to cut off here in a sec, but can you just offer any pointers for somebody who wants to begin learning how to do this well? Besides buy the book.
So I literally have written 500 pages on the book. So
there we go. That's what you just do that, people. And it's a nice book with a great red thing that won't lose your place.
Exactly. Especially if you are into TypeScript and React, I've also published a guide on my blog exclusively about having the right types for common React scenarios. And also going further, I try to pick up situations in my day-to-day work that are either hard to type or are scenarios where having good types for React come in really, really handy. And that's also all on my blog. So
lovely.
That's I guess yeah, it's a shameless plug, plugging somebody's own work, but
not at all.
I write it for a reason. It's just that for me to remember what I learned, and if others can learn from that as well, I think it's nice.
It's very generous of you to do that, honestly. And like I said, people that have written books usually have all their hair pulled out, and you still have your hair, so must be excellent. And this, I think I've learned a lot here, guys. I don't know about you, but this has been excellent.
Yeah, and I've dropped in. I've been Googling, so I dropped in. I found your blog post, and I put a link for your book. And if you're watching this on YouTube, the recording, those will be in the show notes as well. So scroll down and find those and check those out. Well, cool, Stefan. Like, this has been awesome. Like I said, I've legit got some notes here.
Thank you very much. I enjoyed things
I need to do. I know we like to wrap up with a couple last plugs. Is there anything? I think you plugged your book, Dan. Do you have things you want to plug here to wrap us up?
I'll plug the newsletter again, the Enterprise React newsletter, because it's full of great stuff, and they'll never sell your email address.
All right, so I'm going to drop that in the chat, and then I'll drop one more time a link to the React Wednesdays site. Check that out. There's links on there too, where if you want to add upcoming episodes to your calendar. I spent some time fidgeting with that, trying to support more calendars. Found calendars are not, that's something I should blog and do an episode on, because that was a fun couple of days figuring out
Bring Christian
calendar.
along. He can wear you out with calendar weirdnesses.
Calendar support. Yeah, there's dragons in there. But check out upcoming episodes. We got some cool stuff coming up. But thanks one more time, Stefan. This has been really awesome. Thanks for taking the time to join us.
Thank you very much for having me. It's been a blast. So I enjoyed it, especially having somebody to ping pong ideas with. That has been really, really nice. So it's a nice show. I like it.
Awesome.
Excellent.
Well, thanks everybody for joining us. Again, we do this every Wednesday. Come hang out, ask questions, hang out with us. Have a fun time. All right.
Ready.
See you, everybody.
Bye-bye.